Picture this: a dimly lit chamber, thick with the scent of sulfur and burning herbs. A lone figure, cloaked in shadows, bends over a glass vessel as strange liquids hiss and bubble. The flicker of candlelight catches the glint of gold leaf, crushed gems, and cryptic symbols scrawled across parchment. This is the world of the medieval alchemist, a place where science and magic blurred into one, where the line between genius and madness was razor thin. Who were these enigmatic figures? Were they pioneering chemists unraveling the secrets of matter centuries before modern science? Or were they mystical seekers chasing the divine through forbidden experiments? The truth is far stranger than legend. For centuries, alchemists operated in secrecy, guarding their knowledge with codes and symbols. Their quest wasn't just about turning lead into gold, though that was part of it. They sought something even more elusive: the secrets of life itself. Elixirs to cure death, potions to unlock immortality, even the creation of artificial life. These were the dreams that drove them. And yet, their work was so shrouded in mystery that much of it was lost to time, buried in cryptic manuscripts or deliberately destroyed to avoid persecution. What fragments remain tell a story of brilliance, obsession, and sometimes terrifying ambition. Today, we're pulling back the veil on these shadowy figures. We'll explore the real science behind their experiments, the shocking truths hidden in their symbols, and the tantalizing clues they left behind. Some alchemists were visionaries, laying the groundwork for modern chemistry. Others dabbled in forces they barely understood, leaving behind legends of cursed artifacts and unnatural creations. From the forbidden labs of kings to the hidden workshops of rogue scholars, this is the untold story of medieval alchemy, a tale of human curiosity pushed to its limits. So join me as we step into their world, where every flask held a potential miracle or a nightmare waiting to be unleashed. Long before medieval alchemists whispered their secrets in candlelit workshops, the foundations of their craft were being laid in the sun-baked lands of ancient Egypt. Here, among temple priests and skilled metalworkers, the earliest threads of alchemy emerged not as magic, but as a sacred art blending practical chemistry with spiritual wisdom. The Egyptians called it Chem, meaning the black earth, referring both to the fertile Nile soil and the mysterious transformations they observed in metals and dyes. They believed matter itself held divine life, and by mastering its changes, one could touch the powers of the gods. This knowledge traveled across the Mediterranean to ancient Greece, where philosophers like Aristotle theorized that all matter was composed of four primal elements: earth, air, fire, and water. But it was the enigmatic figure of Hermes Trismegistus, a legendary sage said to merge Greek and Egyptian wisdom, who became the mythical father of alchemy. His teachings, later compiled in texts like the Emerald Tablet, claimed that the secrets of the universe could be unlocked through the principle of as above, so below, the idea that the smallest transformations in matter mirrored the greatest cosmic truths. When Rome fell and Europe plunged into the so-called Dark Ages, the flame of alchemy was kept alive in the Islamic world. Arabic scholars like Jabir ibn Hayyan refined Egyptian and Greek techniques, inventing new laboratory tools and recording experiments with startling precision. They gave us words like elixir and alcohol, and their texts translated into Latin centuries later would become the treasured manuals of European alchemists. But the Church viewed this inherited knowledge with deep suspicion. To medieval clerics, the idea of manipulating nature risked usurping God's domain. So alchemists worked in secret, encoding their findings in symbols like the Ouroboros, the serpent eating its own tail, to represent endless transformation without attracting accusations of heresy. By the time these ideas reached Europe, they carried the weight of centuries, part science, part philosophy, all shrouded in danger. Monasteries became unlikely sanctuaries for alchemical study, where monks like Albertus Magnus and Thomas Aquinas cautiously explored these forbidden arts. Their work walked a razor's edge. One misstep could mean accusations of devilry, but success promised not just gold, but a glimpse into the divine blueprint of creation itself. Step inside an alchemist's workshop, and you'd find a world of controlled chaos, a place where the mundane and the mystical collided. The air hung heavy with the sharp tang of vinegar, the earthy scent of crushed herbs, and the metallic bite of molten metals. At the center of it all stood the furnace, a roaring beast of fire and brimstone. This wasn't just for heating, it was the heart of the alchemist's art, where base metals were purified and where the fabled philosopher's stone was said to emerge from the flames. Beside it, glass vessels of every shape glinted in the dim light. Alembics for distillation, their coiled necks designed to capture the spirit of liquids. Pelicans, sealed containers that allowed substances to circulate endlessly, mimicking the cycles of nature. Then there were the more unsettling tools. A mortar and pestle stained with strange powders might have ground everything from common salt to powdered gemstones, or even dried toads believed to hold occult properties. Jars of murky liquids lined rough wooden shelves, some containing what alchemists called the primordial waters, distilled urine, collected over weeks and processed to extract volatile salts. To modern eyes, it seems bizarre, but to these seekers, urine was a treasure trove of hidden substances, a key to unlocking transformation. And let's not forget the manuscripts, leather-bound, crammed with symbols like the sun and moon representing gold and silver, or the caduceus hinting at the union of opposites. Every object had a purpose beyond its physical form. The athana, a slow-burning oven, wasn't just for heat, it symbolized the womb of transformation where matter gestated into higher forms. Even the humble crucible held deeper meaning. The act of melting metals mirrored the alchemist's own spiritual purification, and amidst the clutter, you might spot a curious device called the philosopher's egg, a sealed glass vessel where substances were left to ferment or decay, watched with obsessive patience. To the uninitiated, it looked like junk, but to the alchemist, each item was a thread in the grand tapestry of creation, a way to decode the universe's hidden language. What's fascinating is how much of their work teetered between groundbreaking science and sheer speculation. The same alembics used to brew questionable elixirs also paved the way for modern chemistry equipment. Their meticulous notes on distillation led to breakthroughs in medicine, even as they chased myths. And perhaps that's the real legacy of these workshops, not just the tools, but the relentless curiosity that turned leaden doubt into golden discovery. The philosopher's stone wasn't just a myth, it was an obsession that consumed generations of alchemists, driving them to the edge of reason. At its core, this fabled substance promised two impossible wonders: the power to transmute base metals into gold and the secret to eternal life. But to dismiss it as mere superstition misses the profound symbolism woven into its legend. The stone represented the ultimate triumph of human will over nature, a key to unlocking the universe's hidden order. Some believed it wasn't a physical object at all, but a metaphor for spiritual enlightenment, the moment when the soul, like lead, shed its impurities and achieved perfection. One of the most tantalizing accounts comes from Nicolas Flamel, a humble French scribe who supposedly discovered the stone's recipe in a mysterious book bound in copper. Legend claims he and his wife Perenelle used it to amass sudden wealth, funding hospitals and churches before vanishing without a trace. Historical records show Flamel was real, but his fortune likely came from shrewd property deals, not alchemy. Yet the myth endured, fueled by whispers that he faked his death and still walks among us, immortal. Then there's Paracelsus, the fiery Renaissance physician, who claimed to hold a fragment of the stone, a ruby-red powder he called the alchemist. He used it not for gold, but to heal, insisting it could purge any illness. His rivals scoffed, but his medical breakthroughs, like using clean dressings for wounds, hint that his real genius lay in observation, not magic. Even royalty couldn't resist the stone's allure. Emperor Rudolf II turned his prog court into a haven for alchemists, bankrolling their experiments in exchange for promises of infinite gold. One charlatan, Edward Kelly, dazzled him with sleight-of-hand transmutations until his tricks were exposed, leaving Rudolf bankrupt and disillusioned. But perhaps the most haunting figure was Sendivogius, the Polish alchemist who wrote of holding the stone's white eagle form, only for it to crumble to dust in his hands. His diaries reveal a man torn between wonder and despair, chasing a truth that always seemed to slip away. What's striking is how these stories blur ambition and delusion. For every alchemist documenting careful experiments, another peddled snake oil to desperate patrons. Yet their shared dream to conquer decay, to master matter, mirrors humanity's timeless hunger to transcend limits. In a way, they succeeded. Their relentless search for the impossible laid the groundwork for modern chemistry, even if the stone itself remained forever out of reach. The real philosopher's stone might not be a substance, but the unshakable belief that there's always something more to discover. While the philosopher's stone promised riches, another alchemical obsession whispered of something even more precious: eternal life. Recipes for the elusive elixir of life varied wildly, but many shared a terrifying ingredient: mercury. Alchemists called it quicksilver, believing its liquid metal form mirrored the fluidity of youth itself. Chinese Taoists blended it with gold and jade powder, swallowing it to immortalize the body, a practice that tragically shortened the lives of several emperors, including Qin Shi Huang, who likely died from mercury poisoning while searching for eternity. In Europe, the infamous Countess Elizabeth Bathory bathed in mercury-laced tonics to preserve her beauty, only to descend into madness as the metal ravaged her mind. Yet hidden beneath these deadly experiments lay genuine medical breakthroughs. Paracelsus, despite his mystical reputation, pioneered the use of mercury compounds to treat syphilis, a controversial but effective remedy that remained in use for centuries. Arab alchemists like al-Razi distilled herbal extracts with wine, creating early antiseptics. And in their quest for youth potions, alchemists stumbled upon distillation techniques that gave us essential oils and alcohol-based tinctures still used in medicine today. The line between poison and cure was razor-thin. One alchemist's lethal mercury brew became another's life-saving dose. Perhaps the greatest irony: some of their wildest claims weren't entirely wrong. Modern science now knows gold nanoparticles have anti-inflammatory properties, and mercury, in minuscule doses, was once used in vaccines. The elixir of life remained a mirage, but their relentless experimentation gave us the foundation of pharmacology. In chasing immortality, these seekers accidentally extended countless lives. Their legacy isn't in flasks of liquid gold, but in the hospitals and apothecaries that grew from their risky, relentless curiosity. Beneath the cryptic diagrams and flourishes of medieval alchemy lay a secret language, one where every serpent, celestial body, and fantastical beast held double meanings. Take the Ouroboros, that ancient serpent devouring its own tail. To the uninitiated, it might seem like mere decoration, but alchemists saw it as the ultimate symbol of cyclical transformation. The serpent's endless loop mirrored the purification of metals heated, dissolved, and reborn in the furnace, just as the alchemist's own soul was refined through trial and error. Some manuscripts even depicted the Ouroboros with wings, hinting at the spiritual ascension that came with mastering nature's secrets. Then there were the celestial symbols, the sun and moon, often drawn in delicate balance. Gold and silver were their earthly counterparts, but their meaning ran deeper. The sun represented the masculine principle, active, fiery, the spark of creation, while the moon embodied the feminine, receptive, fluid, the vessel that shaped matter. When an alchemist drew them conjoined, it signaled the sacred marriage of opposites, a fusion that could birth the philosopher's stone. This duality echoed everywhere, from the acid and alkali solutions they mixed to the very structure of their labs, where furnaces male and alembics female worked in harmony. But few symbols baffle modern readers like the green lion. Far from a literal beast, it symbolized raw, unrefined matter, often iron sulfate, a vivid green compound that could devour lesser metals like a predator. When an alchemist wrote of feeding the green lion, they meant dissolving gold in aqua regia, a volatile mix of acids that reduced the noble metal to a base state ready for rebirth. Even the color held meaning. Green was the hue of vitality, the intermediate stage between decay and renewal. Decoding these symbols wasn't just about chemistry, it was survival. In an era where heresy accusations loomed, alchemists cloaked their work in allegory. A recipe for purifying mercury might be written as the virgin fleeing the fiery dragon, masking practical lab steps behind poetic metaphor. The irony these very codes meant to conceal became a shared language across borders, allowing alchemists from Damascus to Paris to recognize each other's work. Today, we see their legacy in modern science's own symbols, the atomic models, chemical equations, and even the recycling logo, all descendants of a visual shorthand born in smoky medieval workshops. Albertus Magnus wasn't just an alchemist, he was a force of nature, a man whose intellect burned so brightly that legends claimed he could command the weather itself. Born in the late 12th century, this Dominican friar became one of the Middle Ages' most prolific scholars, writing volumes on everything from astronomy to zoology. But it was his alchemical work that blurred the line between science and sorcery. He documented experiments with arsenic and sulfur, meticulously recording how metals reacted under heat centuries before the periodic table. Yet his most enduring legacy might be his pupil, Thomas Aquinas, the towering theologian who credited Albertus with teaching him that nature and divinity were 2 pages of the same sacred text. Later myths would exaggerate his feats, whispering that he'd crafted a brass head that could prophesy, or that he'd summoned springtime in the dead of winter to impress visiting nobles. The truth, his real magic was his insistence that observation, not superstition, should guide human understanding. Then there's Roger Bacon, the Dr. Mirabilis, the wonderful teacher. This 13th century Franciscan friar was less interested in turning lead into gold than in unlocking the raw potential of human knowledge. His manuscripts crackle with ideas that seemed heretical at the time: flying machines, telescopic lenses, even what we'd now recognize as gunpowder. Bacon saw alchemy as a tool for societal transformation, dreaming of elixirs that could heal the sick and metals that could build a better world. His boldness cost him dearly. The church imprisoned him for suspected novelties, fearing his inventions might upend the natural order. Yet his writings survived, smuggled out of his cell by sympathetic monks. Centuries later, scholars would realize just how prescient he'd been. His sketches of mechanical boats and horseless carriages eerily predicting technologies yet to come. And of course, there's Nicolas Flamel, the alchemist who cheated death, or so the stories insist. A real-life scribe and bookseller in 14th century Paris, Flamel's name became synonymous with the philosopher's stone after his death. Rumor claimed he discovered its secrets in a cryptic manuscript, using it to amass wealth and achieve immortality. Sightings of Flamel persisted for centuries, a traveler spotting him in a Swiss monastery in the 1700s, a Parisian butcher swearing he'd sold the man meat in the 1920s. The chilling twist: Flamel's real fortune came from mundane property deals, and his tomb in Paris's Musée de Cluny is very much occupied. But the myth endures, a testament to humanity's hunger for eternal life. What unites these figures isn't just their intellect, but their ability to straddle worlds, part scientist, part mystic, wholly unafraid of the unknown. Albertus sought God in the crucible, Bacon in the stars, Flamel in the pages of a book. Their real legacy isn't in the gold they may or may not have made, but in the questions they dared to ask. And sometimes the right question is more valuable than all the answers in the world. The Church's relationship with alchemy was a paradox, both a fierce persecutor and a quiet patron. On one hand, religious authorities condemned alchemists for dabbling in forces they deemed unholy, accusing them of trafficking with demons or attempting to usurp God's power over creation. Yet behind closed doors, some of the most powerful figures in Christendom secretly funded their work. Pope John XXII, who publicly denounced alchemy as fraudulent and devilish in a 14th century papal decree, was rumored to have employed Jewish alchemists to replenish the Vatican's coffers. His private ledgers, discovered centuries later, revealed payments for certain powders and transmutative experiments, a hypocrisy that mirrored the era's tension between faith and curiosity. The allure of gold was impossible to resist, even for the devout. Monasteries became unlikely hubs of alchemical study, where monks like Basil Valentine, a shadowy figure who may have been a collective pseudonym, wrote treatises on dissolving metals in sharp waters, acidic solutions, while framing their work as spiritual allegory. The Benedictines, in particular, preserved ancient alchemical texts, copying them by candlelight under the guise of theological study. Their labs, hidden beneath abbey kitchens, were sanctified as spaces where the divine and the earthly could commune. One surviving manuscript from a German monastery shows a crucified Christ surrounded by alchemical symbols, blending redemption with the quest for transformation. But not all clergy were so accommodating. The Inquisition hunted down alchemists with the same fervor it reserved for heretics and witches. The case of Giordano Bruno, burned at the stake in 1600, reveals how dangerous these pursuits could be. Though Bruno was condemned primarily for his cosmological theories, his interest in Hermeticism and alchemy sealed his fate. The Church feared these arts because they threatened its monopoly on truth. If humans could unlock the secrets of creation, what need had they for divine intercession? This tension birthed secret societies like the Rosicrucians, who wove Christian mysticism into alchemical symbolism. Their manifestos, published in the early 17th century, spoke of an invisible college of adepts who'd mastered nature's laws. Some historians believe these groups served as underground networks, safeguarding knowledge from destruction. Ciphered letters between members referenced the great work and soul purification, masking chemical processes in spiritual terms to evade detection. Even the Freemasons, though not alchemists themselves, inherited this coded tradition, using symbols like the compass and square to echo the alchemist's balance of opposites. The Church's dance with alchemy was a waltz of fear and fascination. It condemned what it couldn't control, yet coveted what it couldn't create. In the end, the very secrecy it forced upon alchemists may have preserved their ideas, allowing them to simmer in hidden crucibles until science was ready to inherit their flame. History books often paint alchemy as a world of hooded men, hunched over smoky furnaces, but hidden in the margins were women who shaped its very foundations. Take Mary the Jewess, a shadowy figure from ancient Alexandria whose inventions still echo in modern labs. She gave us the bain-marie, that gentle water bath used to heat substances evenly. Chefs know it today for melting chocolate, but alchemists revered it as the balneum Mariae, Mary's bath, a sacred vessel where matter could transform without violent force. Her other devices, like the tribicos, a three-armed still for distilling acids, became staples in medieval workshops. Legends claim she could make silver, sweat, and gold grow, but her real genius lay in recognizing that patience, not brute heat, unlocked nature's secrets. Noblewomen often pursued alchemy behind convent walls, where the veil offered both spiritual refuge and intellectual freedom. The 12th century Abbess Hildegard of Bingen brewed medicinal elixirs from herbs and gemstones, documenting their effects in coded manuscripts. Her Book of Subtleties mixed mysticism with startlingly accurate remedies like using crushed emeralds for heart ailments, a precursor to modern magnesium treatments. Then there's Nicolas Flamel, often reduced to a footnote in her husband Nicolas's legend. Yet period records suggest she wasn't just an assistant, she managed their Parisian laboratory, decoding ancient texts while fending off thieves and spies. When Nicolas died, she vanished without a trace, fueling whispers she'd perfected the elixir of life and fled to avoid persecution. Even royalty dabbled. Isabella d'Este, the Renaissance First Lady of the world, turned her Mantua court into an alchemical salon, hosting debates between scholars and commissioning exquisite glassware for experiments. Her letters reveal a razor-sharp mind probing the limits of nature. If gold can be made to flower in a vial, why not the human soul? But these women faced dangers men never did. When the brilliant Caterina Sforza was captured by Cesare Borgia, her captors tortured her for her alchemical recipes, especially the one for virgin's milk, a pearlescent mercury compound believed to heal wounds. She famously threw her notes from the castle walls rather than surrender them, shouting, "Now you hold only the paper, not the art." Their legacy lingers in unexpected places. The bain-marie still graces laboratories. Hildegard's herbal blends inspire modern pharmacologists, and the symbols they used, like the serpent-entwined chalice, representing both the poisonous and healing powers of their craft, evolved into the pharmacy's caduceus. These women weren't anomalies, they were pioneers who turned oppression into opportunity, proving that curiosity knows no gender. Their workshops weren't just rooms, they were revolutions in glass jars. At first glance, alchemy and early science seem worlds apart, one shrouded in symbolism and secrecy, the other championing observation and open inquiry. But the truth is more nuanced. Both traditions sought to unravel nature's mysteries, just through different lenses. Where Renaissance scientists like Galileo relied on telescopes and mathematics, alchemists turned to allegory and analogy, believing the macrocosm and microcosm mirrored each other. Yet their tools often overlapped. The same furnaces that melted metals for transmutation also purified substances for medical use, and the meticulous notes alchemists kept on reactions became the foundation of modern lab records. No one embodies this bridge better than Paracelsus, the bombastic Swiss physician who tossed traditional medical texts onto a bonfire and declared nature itself the only true teacher. He infuriated the establishment by prescribing mercury and arsenic compounds, substances alchemists had long experimented with to treat diseases. While his doses were dangerously imprecise by today's standards, his radical idea that minerals, not just herbs, held healing power revolutionized medicine. He called his approach spagyrics, blending alchemical extraction methods with clinical observation. When he wrote that the dose makes the poison, he wasn't just justifying risky treatments, he was articulating a principle that modern pharmacology still relies on. The real divergence between alchemy and science lay in their end goals. Alchemists sought universal truths, the philosopher's stone, the elixir of life, while early scientists like Robert Boyle focused on incremental, reproducible discoveries. Yet even Boyle, often called the father of modern chemistry, secretly practiced alchemy, encoding his transmutation attempts in private diaries. His landmark work, The Skeptical Chemist, criticized alchemical obscurantism but borrowed its experimental techniques like distillation and crystallization. The irony, alchemy's relentless trial and error, documenting every failed fusion or discolored residue, taught scientists the value of process over dogma. What finally tipped the scales was accountability. Alchemists wrote for initiates, their manuscripts filled with riddles like "The green lion devours the sun." Scientists, by contrast, began publishing clear, replicable methods. When Andreas Libavius, a German chemist, penned the first definitive chemistry textbook in 1597, he included precise instructions for creating acids free of allegory. Yet even he couldn't resist one alchemical holdover. His frontispiece showed an allegorical figure holding both a flask and a torch, symbolizing the union of hands-on experiment and enlightened reason. The legacy of this shift is everywhere. The alchemist's furnace evolved into the chemist's Bunsen burner. Their symbolic shorthand for elements paved the way for the periodic table. And their obsession with transformation echoes in modern nanotechnology, where scientists manipulate matter atom by atom. Perhaps the deepest truth is this: alchemy wasn't the antithesis of science, but its restless, dreaming precursor, a reminder that every groundbreaking discovery begins with someone daring to ask, what if? For an alchemist, writing down a discovery could be as dangerous as it was valuable, which is why their manuscripts are riddled with codes, ciphers, and visual riddles designed to baffle the uninitiated. Take the enigmatic Rebus writing, where words were replaced with images or puns. A recipe for dissolving gold might show a drawing of the sun representing gold being swallowed by a wolf, symbolizing antimony, a metal that devours others in reactions. To the untrained eye, it looks like a bizarre comic strip, but to fellow adepts, every doodle was a precise laboratory instruction. The famous Ripley Scroll, a 15-foot-long illustrated manuscript, is a masterclass in this visual shorthand. Its dragons, fountains, and bleeding kings all correspond to chemical processes like distillation or the extraction of mercury from ore. Even more elaborate were the ciphers, some so complex they remain unsolved today. Alchemists used everything from simple letter substitutions like swapping Latin for Greek alphabets, to layered codes where a single symbol could mean different things depending on its color or position. The notorious Book of Abraham the Jew, a text sought by figures like Nicolas Flamel, was said to be written in a celestial script that changed meaning when held under moonlight. Modern scholars, armed with spectral imaging and AI pattern recognition, have cracked some of these puzzles. For instance, a 15th-century manuscript initially dismissed as gibberish was recently decoded as instructions for making nitric acid, its zigzag lines representing the corrosive liquid's erratic bubbling. No figure embodies the intersection of cryptography and alchemy more than Isaac Newton. While he's celebrated for his laws of motion, fewer know he spent decades obsessively decrypting alchemical texts, filling notebooks with over 1 million words of analysis. Newton believed ancient adepts had hidden the secrets of gravity and light within their allegories, and he painstakingly translated obscure terms like the green lion into tangible chemical reactions. His breakthrough came when he realized that Diana's doves, a recurring image in texts, referred to the silver chloride formed when silver dissolves in nitric acid, a reaction that produces a white precipitate resembling wings. Yet even Newton met his match with some codes. His frustrated marginalia in one manuscript reads simply, "This is unintelligible." What's fascinating is how these codes served dual purposes. They protected alchemists from persecution, yes, but they also acted as a filter, ensuring only those willing to dedicate years of study could access the knowledge. A single manuscript might require understanding Greek mythology, medieval astrology, and practical chemistry just to decode one page. Today, these puzzles offer a glimpse into a mindset where science and poetry weren't opposites, but partners in unraveling the universe's mysteries. The real philosopher's stone, perhaps it wasn't a substance, but the perseverance to keep deciphering one glyph at a time. The same hands that stirred molten metals also brewed medicines that saved lives, because medieval alchemy wasn't just about gold. It was a cradle for pharmacology, where mystical recipes often hid startlingly effective treatments. Take the so-called sun syrup, a golden elixir made from saffron and scent. John's wort, alchemists claimed it captured sunlight in liquid form to banish melancholic humors. Today, we recognize it as an early antidepressant scent. John's wort contains hypericin, a compound still used in herbal mood therapies, but the genius lay in their delivery. By dissolving these herbs in wine or vinegar, they unwittingly enhanced absorption, creating a primitive but potent tincture. Even more revolutionary were their antiseptics. When the Black Death ravaged Europe, alchemists like John of Rupecissa distilled quintessence of wine, what we'd now call ethanol, to cleanse wounds. His manuscript De Consideration Quinti Essentii framed it as a celestial balm, but the science was sound. Alcohol killed bacteria centuries before germ theory. Other texts prescribed mercury ointments for ulcers, a brutal yet effective treatment that sterilized infections at the cost of poisoning the patient slowly. The line between cure and toxin was perilously thin, but their trial and error laid groundwork for modern antibiotics. What's fascinating is how they cloaked these breakthroughs in allegory. A recipe for dragon's blood salve might call for powdered oak gall and copper salts, ingredients we now know have astringent and antimicrobial properties. The dragon, merely a code for infection, its blood the healing agent that slew it. Monasteries became covert centers for this research, with monks like Roger Bacon encrypting formulas in psalms or holographic ink that appeared only under candlelight. One Benedictine manuscript, disguised as a hymn book, contained step-by-step instructions for distilling antiseptic thyme oil between verses about divine mercy. Not all their ideas were benign. Some elixirs contained hallucinogenic henbane or deadly nightshade, prescribed for pain but inducing delirium. Yet even these missteps proved instructive. The violent reactions they recorded helped later physicians identify toxic thresholds. And when alchemists like Paracelsus began mapping diseases to specific mineral deficiencies, they stumbled onto concepts like trace elements long before modern nutrition science. The real legacy of these potion makers isn't in their mysticism, but in their meticulous documentation. Every bubbling flask, every discolored residue was logged in symbols we're still deciphering. Their green lion might be iron sulfate for anemia, their tears of the moon, silver nitrate for eye infections. What we once dismissed as superstition was often science in disguise, a reminder that progress wears many guises, and sometimes the most powerful medicine comes wrapped in a riddle. For every genuine seeker of alchemical truth, there were a dozen charlatans ready to exploit the desperate and the greedy. The courts of Europe swarmed with so-called puffers, alchemists who earned their nickname from endlessly stoking their furnaces, producing nothing but smoke and empty promises. One notorious figure, Marco Bragadino, wove a web of deception so elaborate it ensnared half the nobility of 16th century Germany, claiming he could conjure gold from mercury using a divine red powder. He dazzled patrons with staged demonstrations, secretly slipping gold flakes into crucibles during his theatrics. His downfall came when the Duke of Bavaria demanded a public test under armed guard. With no chance to cheat, Bragadino's trickery collapsed, and he swung from a gilded gallows, a grim warning to would-be frauds. Not all punishment was so swift. Emperor Rudolph II, desperate to refill his depleted treasury, kept the English alchemist Edward Kelly in a gilded prison for years, demanding daily transmutations. Kelly, once an assistant to the brilliant John Dee, had convinced Rudolph he possessed the Philosopher's Stone, using sleight of hand to transform base metals with hidden gold amalgams. When his tricks faltered, Rudolph ordered him confined to a castle tower, shackled until he produced results. Kelly's eventual escape attempt left him crippled after a fall from the ramparts, a broken man who traded his integrity for royal favor. The darkest tales, however, come from the shadows of the Inquisition. In 1586, the Spanish alchemist Diego de Santiago was burned at the stake not for failure but for suspicious success. His crime, producing gold that was too pure. Church inquisitors, certain such perfection could only come from a pact with the devil, condemned him after his own patron turned him in, fearing divine wrath. De Santiago's final words, "I die for knowing too much," haunted alchemy for centuries. What made these scams so pervasive was the era's volatile economy. With monarchs constantly at war, gold reserves dwindled and alchemists became fiscal lifelines. the French King Charles VI employed over 300 projectors to manufacture currency alchemical alloys, debasing coins until they sparked runaway inflation. When the scheme collapsed, Parisian mobs lynched alchemists in the streets, their bodies left hanging with lead coins stuffed in their mouths, the ultimate irony for those who'd promised to turn it into gold. Yet not all deception came from fraudsters. Some alchemists, like the enigmatic Count of Saint-Germain, blurred the line between con artist and visionary. A favorite of Louis XV, Saint-Germain claimed to be centuries old, showing off flawless diamonds he insisted were manufacturable through alchemy. While his gems were likely smuggled, his real allure lay in his uncanny knowledge of forgotten chemical techniques, like removing flaws from stones with acid washes. Was he a thief or a misunderstood genius? History still debates his legacy. These stories reveal a bitter truth. For all its lofty aspirations, alchemy's reputation was tarnished by those who peddled lies as enlightenment. But their downfall also marked a turning point as rulers grew wary. They began demanding verifiable results, nudging alchemy toward the rigor of modern science. The line between fraud and discovery, it seems, was as volatile as the chemicals they stirred. Open any medieval alchemical manuscript and you'll find a world where science collides with surreal dreams. These vivid illustrations weren't just decorative. They were a secret language, a way to encode dangerous knowledge in plain sight. Take the infamous chemical wedding, a recurring motif showing a king and queen submerged in a flask or locked in an embrace. To the uninitiated, it might seem like a bizarre fairy tale, but alchemists saw it as the heart of their craft. The royal couple represented sulfur and mercury, the parents of all metals, and their union symbolized the purification process needed to create the Philosopher's Stone. The flames beneath the flask weren't just decoration, they hinted at the precise heating required to trigger the reaction, a visual recipe hidden in symbolism. Even stranger were the bestiaria, fantastical creatures crowding these pages. Dragons, often depicted with wings or multiple heads, weren't mythical beasts but representations of volatile substances. A winged dragon might signify mercury, its ability to fly when heated mirroring the metal's evaporation. A dragon devouring its own tail, the Ouroboros, wasn't just a pretty spiral but a coded lesson in cyclical distillation, where liquids were boiled, condensed, and reborn in an endless loop. And those eerie homunculi, tiny human figures floating in flasks, they weren't attempts to create life, as later legends claimed, but personifications of chemical solutions at different stages of refinement. Some of the most perplexing images held the most practical instructions. The tree of the metals, with its roots in earth and branches bearing suns and moons, was a flowchart for ore refinement. Each fruit represented a metal at varying purity levels, while the serpent coiled around the trunk indicated the corrosive acids needed to separate them. Even colors carried precise meaning. A red lion symbolized gold oxide, while a white eagle stood for ammonium chloride, a compound used to purify metals. These weren't arbitrary choices, they were a visual shorthand, allowing alchemists from Cairo to Cologne to share techniques without risking persecution. The brilliance of this system lay in its layers. A single image could simultaneously depict a lab procedure, a spiritual allegory, and a cosmic principle. Consider the sun and moon bathing in a fountain, a common scene showing celestial bodies immersed in water. On one level, it illustrated the dissolving of gold and silver in acid. On another, it echoed the alchemist's belief that metals grew in the earth like living things, nourished by subterranean fluids, and for the mystic, it symbolized the soul's purification through divine wisdom. This multi-layered approach wasn't just artistic, it was survival. If the church confiscated a manuscript, the illustrations could be dismissed as heretical nonsense, while initiates saw a detailed lab manual. Modern scientists are still unraveling these visual puzzles. Spectral imaging has revealed hidden underdrawings in manuscripts like the Ripley Scroll, where seemingly random doodles of toads and fountains overlay precise chemical diagrams. Infrared scans show earlier, more technical sketches beneath the ornate final versions, proof that these artists were working from real experiments, not just imagination. The more we decode, the clearer it becomes. These weren't the ravings of deluded mystics, but the work of brilliant minds who had to disguise their genius as madness to keep it alive. Their art was more than illustration, it was alchemy in its purest form, transforming base ink into golden knowledge. Royal courts weren't just centers of power, they were cauldrons of alchemical ambition, where the quest for gold twisted into high-stakes political theater. No monarch exemplified this more than Rudolf II, the Habsburg ruler who turned Prague Castle into a glittering magnet for Europe's most controversial minds. Obsessed with unlocking nature's secrets, he lured alchemists with promises of lavish patronage, but there was a catch. Those who failed to produce gold faced imprisonment in the very towers they'd been hired to enrich. Rudolf's court became a gilded cage where scholars like John Dee and Edward Kelly performed transmutations under armed guard, their experiments scrutinized for even a fleck of precious metal. The emperor's motives weren't merely financial. In an era where a kingdom's strength was measured by its treasury, controlling alchemy meant wielding an economic weapon. A ruler who could manufacture gold could fund endless wars, outlast rivals, and even destabilize entire currencies. But Rudolf wasn't alone in this game. France's Charles VI employed a secret network of alchemists to debase coinage, blending precious metals with cheaper alloys to stretch his dwindling reserves. When neighboring kingdoms discovered the scheme, it sparked diplomatic crises and counterfeiting panics, early examples of economic warfare. In England, Henry VI bankrolled teams of projectors to alchemically bolster the crown's finances, while Elizabeth I kept her own court alchemist, Cornelius de Lannoy, under constant surveillance after rumors spread he'd gifted her a vial of liquid gold. The line between genius and fraud was perilously thin, and monarchs played both sides, publicly condemning alchemy as heresy while quietly funding it in basements and towers. The political calculus was ruthless. Alchemists who succeeded became indispensable, like the shadowy figure known only as Salomon Trismegistus, whose alleged gold-making prowess earned him a manor and titles from a desperate German prince. Those who failed met grisly ends, hung with gilded nooses or forced to drink their own elixirs to prove their purity. Yet the greatest threat wasn't execution, it was the risk of knowledge falling into enemy hands. When the Swedish army stormed Prague in 1648, their first prize wasn't art or jewels, it was Rudolf's seized alchemical manuscripts, hauled back to Stockholm as spoils of war. What's chilling is how these schemes mirrored the alchemical process itself. Kings treated court alchemists like base metals, applying pressure, heat, and isolation to force transformation. Some emerged as revered advisors, like Michael Sendivogius, who parlayed his chemical talents into diplomatic roles between Polish and Austrian courts. Others, like the ill-fated Marco Bragadino, became cautionary tales, their gilded promises dissolving into ash. In the end, these royal experiments revealed a bitter truth. The real philosopher's stone wasn't a substance but power, and like lead exposed to false gold, it always corrupted in the end. While Christian and Islamic alchemists dominated the historical spotlight, a vibrant tradition thrived in the shadows: Jewish alchemy, where science and mysticism intertwined under constant threat. Unlike their counterparts, Jewish practitioners faced a brutal paradox. Their expertise in metallurgy and medicine made them invaluable to kings and popes, yet their faith marked them as perpetual outsiders. Take the legendary Maria Hebrea, known as Mary the Jewess, whose 3rd century inventions like the water bath bain-marie and distillation apparatus became foundational tools across Europe. Her treatises on sulfuric acid production circulated secretly for centuries, preserved in Arabic translations after Christian authorities destroyed original Hebrew texts. For Jewish alchemists, coding knowledge was a matter of survival. During the Spanish Inquisition, families like the Ibn Ezras disguised formulas within Kabbalistic numerology, where letters doubled as chemical measurements. A passage about the fiery chariot of Ezekiel might detail copper smelting temperatures, while the 12 tribes represented proportions in alloy mixtures. This subterfuge reached its zenith with the enigmatic Abraham Elixir, whose 1,735 manuscript Ural's Chimish's work contained elaborate alchemical symbols overlaid with Hebrew letters, a cipher only cracked in 2019, revealing precise instructions for creating nitric acid. Persecution forced innovation. When 13th century French Jews were banned from owning land, many turned to apothecary work, perfecting alcohol distillation to produce medicinal tinctures. Their quintessence of wine, a potent ethanol solution, became prized by surgeons for sterilizing wounds, though church records labeled it Jewish sorcery. In Prague, the ghetto's alchemists developed amalgamation techniques to refine silver for coins, a skill that granted them precarious protection from pogroms. Rabbi Judah Loew ben Bezalel, famed for the golem legend, reportedly experimented with mercury-based alloys, though his notes were burned by Christian scholars who called them diabolical texts. The tragedy lies in how much was lost. When Jewish communities were expelled from England in 1290, Germany in 1348, and Spain in 1492, their alchemical libraries, often the most advanced in Europe, were confiscated or destroyed. Fragments survived in coded recipe books smuggled in Torah casings, like the Sephardic scrolls discovered in 2004 beneath a Lisbon synagogue. These contained groundbreaking formulas for vitriol sulfuric acid production, centuries before Paracelsus claimed the discovery, yet their legacy endures. Modern chemistry owes terms like alkali from the Hebrew al-kali, meaning ashes, and techniques like fractional crystallization to these persecuted scholars. The real transmutation they achieved wasn't lead into gold, but oppression into enduring knowledge, proof that even the darkest crucibles can yield brilliance. The alchemist's crucible wasn't just a vessel, it was a stage for some of history's most audacious performances, where lead and copper took center roles in a drama to rival the gods. Take the infamous experiment by 16th century alchemist Bernard of Treviso, who spent 40 years mixing metals with everything from eggshells to human blood, convinced the secret lay in nature's hidden sympathies. His final attempt involved dissolving mercury in nitric acid with a pinch of powdered ruby, a process that produced a startling red vapor but no gold. What Bernard didn't realize was that he'd accidentally created mercury fulminate, an explosive compound that would later be used in firearms. His failure wasn't just bad chemistry, it revealed a fundamental truth centuries ahead of its time. Metals couldn't be transformed by mere heat or chemical reactions alone. The real key lay buried in the atom's heart, waiting for the dawn of nuclear physics. Occasionally, though, nature threw alchemists a tantalizing bone. When Heinrich Kunrath, a German practitioner, heated a mixture of tin and antimony sulfide, the surface shimmered with a golden sheen, a trick of light refracting through metallic crystals that sent him racing to patrons with claims of success. What he'd actually made was purpurine, a violet-tinted alloy that medieval jewelers used as a cheap gold simulant. Similar accidents fueled legends. The gold produced by boiling copper with urine was just brass, formed when zinc impurities in the urine bonded with the metal. These illusions weren't mere deceptions, they were glimpses into material science that would later explain alloys and surface plating, the cruelest irony. Alchemists were touching the edges of atomic theory without the tools to grasp it. When Georgius Agricola described lead ore releasing a noble spirit during smelting, he was witnessing trace amounts of gold, about 1 part per million, separating from the molten metal. To Renaissance eyes, this seemed like partial transmutation. In reality, the gold was always there, hidden within the lead's molecular structure like a needle in a haystack. It took 20th century particle accelerators to prove what alchemists had suspected. Gold could be made from other elements, but only by rewriting atomic nuclei, a process requiring energies equivalent to a supernova. The most heartbreaking attempts came from those who nearly grasped the truth. 18th century chemist James Price, convinced he'd perfected a mercury-based transmutation, invited England's Royal Society to witness his method. When skeptics demanded he repeat the experiment with their materials, his failure drove him to suicide by drinking his own elixir, a fatal dose of mercury chloride. Modern analysis suggests his original success might have involved gold-coated flasks, but his desperation reflects the crushing weight of alchemy's ultimate dream. For all their ingenuity, these seekers were like children trying to rebuild a watch with hammers, close enough to see the gears, but centuries away from understanding what made them turn. Yet their legacy survives in unexpected places. Today's nanotechnology uses atomic-level manipulation to create alchemical effects, gold nanoparticles that appear purple or red, or materials that change properties under specific conditions. The old masters would weep to know we achieved their dreams not with mystic symbols, but with electron microscopes and quantum physics. Their furnaces may have failed to make gold, but they lit the fire that forged modern science. Before dawn's first light, an alchemist's day began in hushed secrecy. The workshop, often tucked away in a cellar or behind an unmarked door, hummed with quiet intensity. Candles flickered as they measured powders with obsessive precision, their scales calibrated to the weight of a barleycorn, a medieval unit so fine it could detect the difference between genuine gold leaf and a clever forgery. Each movement was deliberate, each ingredient logged in cipher-laden journals. This wasn't just chemistry, it was a sacred ritual where a single misstep could mean wasted months or worse, a lethal explosion. Sourcing materials was a dance of diplomacy and danger. Wealthy patrons might supply exotic items like Ethiopian emeralds or Baltic amber, but lesser alchemists bartered with apothecaries, miners, and even grave robbers for essentials. A typical shopping list read like a witch's grimoire: mercury, quicksilver smuggled from Spanish mines, antimony pried from Hungarian ore, and the infamous dew collected at full moon, actually rainwater filtered through specific herbs to trap volatile compounds. Some went further. The Zurich alchemist Conrad Gessner wrote of gathering mandrake root at the witching hour, its hallucinogenic properties believed to open the mind to hidden truths. Others sought dragon's blood, not the mythical creature's sap but a resin from Indonesian trees, prized for its vivid hue in tinting glassware. Apprenticeship was a trial by fire, sometimes literally. Young boys, rarely girls, unless hidden like Nicolas Flamel, entered service as bellows monkeys, tasked with maintaining furnace temperatures for days on end. Their fingers bore burns from spilled acids, their lungs choked on arsenic vapors. In exchange, they learned the art's layers, how to read the color of flames, blue for mercury's peak volatility, red for gold's melting point, the secret meanings of coded manuscripts, and the perilous skill of handling oil of vitriol, sulfuric acid that could dissolve flesh. The most trusted were taught the green language, where phrases like the crow's head signaled the blackening stage of oxidation, and the peacock's tail meant iridescent layers of purification. But the true test came in solitude. Masters often vanished for weeks seeking materia prima, the primal substance believed to underpin all matter. Some scoured caves for philosopher's salt, actually sodium nitrate deposits, while others distilled hundreds of gallons of urine for phosphorus, a glowing element first isolated by alchemist Brand in 1669 after boiling down 50 buckets of human waste. The work was grueling, reeking, and occasionally deadly, yet in these grim routines breakthroughs flickered. The same urine experiments yielded ammonium salts used in dyes, and those moonlit dew collections advanced distillation techniques still used in perfume making today. The alchemist's life wasn't just about flasks and furnaces. It was a tightrope walk between reverence and recklessness. Every ingredient, no matter how grotesque, held potential. Every failed experiment was a step closer to revelation. And though their quest for gold often ended in ash, their relentless curiosity forged something far more enduring, the unshakable belief that nature's secrets were worth any sacrifice. To an alchemist, the night sky wasn't just a spectacle, it was a celestial laboratory where the fates of metals and men intertwined. They believed every metal pulsed with the energy of a distant planet. Gold shimmered with solar fire, silver carried the moon's cool glow, and iron resonated with Mars's warlike vibrations. This wasn't mere poetry, it was a working theory that shaped their experiments down to the hour. When an alchemist dissolved silver under a full moon, they weren't following superstition, but what they saw as celestial synergy, matching lunar phases to the metal's feminine, receptive nature. Even the humblest furnace was aligned to capture planetary influences, positioned at angles where astrological charts suggested maximum potency. The zodiac became their scheduling calendar. Taurus, ruled by Venus, was the ideal time to work with copper, the metal linked to love and beauty. Scorpio's watery intensity governed Mercury's fluid transformations, while Leo's fiery domain was reserved for gold's purification. Manuscripts like the Emerald Tablet explicitly instructed adepts to separate earth from fire only when the sun enters Aries, believing the ram's bold energy would catalyze reactions. Some alchemists took this further, engraving constellations onto their glassware or timing distillations to planetary hours, dividing each day into segments ruled by specific celestial bodies. A surviving German manuscript from 1523 details a Mercury experiment begun precisely at the first hour of Mercury on a Wednesday, the day named for the planet itself. This cosmic choreography yielded some surprisingly practical results. When medieval metallurgists smelted ore during Jupiter's benefic phases, they unknowingly avoided humid weather that could ruin their furnaces. Jupiter's traditional association with clear skies made it a safe bet. And those who distilled herbal elixirs under Virgo's influence often chose late summer when plants were at peak potency, but the system had its pitfalls. Danish astronomer Tycho Brahe, himself a clandestine alchemist, lamented how colleagues wasted months waiting for auspicious alignments while their reagents spoiled. His hybrid approach, recording celestial patterns alongside chemical outcomes, laid groundwork for the scientific method, though he still buried a zodiacal calendar beneath his lab at Uraniborg. The most haunting legacy of this astro-alchemy lies in its symbols. The same glyph for Mars' male sign that marked iron in manuscripts now labels male gender in biology, while Venus's mirror female sign denotes both copper and femininity. Even the planetary metals persist in modern chemistry's language: lunar caustic for silver nitrate, saturnine for lead poisoning. What these seekers glimpsed, the profound connection between cosmic cycles and earthly matter, wasn't entirely wrong. We now know solar radiation affects metal conductivity, and tidal forces subtly alter chemical reactions. Their mistake was attributing it to gods rather than gravity and electromagnetism. In chasing the stars' secrets, they charted a path to truths far stranger than their myths. Among the labyrinth of cryptic illustrations and fading ink, the Ripley scroll stands as one of alchemy's most dazzling and perplexing artifacts. Stretching over 15 feet of vellum, this 16th century masterpiece is less a manuscript than a visual riddle, where dragons, kings, and celestial orbs intertwine with cryptic verses. At first glance, it resembles a medieval comic strip, but every flourish holds meaning. The central image, a serpent coiled around a golden tree, isn't just decoration. It encodes a distillation process using antimony, a metal alchemists believed could purify gold. Nearby, a crowned king dissolves in a flask, symbolizing the dissolution of raw metal in acid, while a winged queen represents the volatile vapors captured during heating. What makes the scroll extraordinary isn't just its artistry, but its survival. Unlike treatises burned as heresy, this one was likely hidden within noble libraries, passed between initiates who added their own annotations like layers of a palimpsest. Modern technology is finally cracking its secrets. Multispectral imaging, a technique that captures light wavelengths beyond the visible spectrum, has exposed faded notes and underdrawings invisible to the naked eye. In 2018, researchers at the University of Cambridge discovered erased marginalia in the scroll's corners, numerical ratios likely denoting precise furnace temperatures. Even more startling, ultraviolet fluorescence revealed traces of orpiment, a toxic arsenic sulfide pigment, suggesting the original illustrator suffered skin lesions from handling these materials. Another breakthrough came with X-ray fluorescence scanning, which detected mercury residues in the blood dripping from the scroll's alchemical pelican, a vessel symbolizing cyclic purification. This wasn't just metaphor, it proved the artist had first-hand knowledge of mercury distillation, a dangerous process few dared to document, but the Ripley scroll isn't alone. The Voynich manuscript, that infamous 15th century puzzle of undeciphered script and bizarre botanical drawings, has yielded clues through carbon dating and AI pattern analysis. While not strictly alchemical, its zodiacal charts and tubular roots mirror contemporaneous herbals used in potion making. Then there's the Buch der Heiligen Dreifaltigkeit, a German text where gold leaf and lapis lazuli pigments hide subtexts literally. Conservators at the Getty Museum found that scraping away a thin top layer of paint exposed alternative recipes beneath, likely added by later owners censoring heretical methods. Perhaps the most poignant discoveries come from manuscripts thought lost. In 2021, a palimpsest in a Bologna archive revealed traces of a 9th century Arabic alchemical tract beneath a later Christian hymn book. The original, written with iron gall ink, had faded, but hyperspectral imaging resurrected its erased equations for creating noble waters, distilled acids. This wasn't just recovery, it was resurrection, proving how much knowledge was overwritten by dogma. What emerges from these texts isn't mere superstition, but a sophisticated intellectual tradition. The Ripley Scroll's Garden of the Philosophers isn't fantasy, it's a flowchart for sequential reactions, where each flower represents a different stage of purification. Modern chemists recognize these steps as precipitation, filtration, and reflux, albeit cloaked in allegory. The real magic lies in how these scholars communicated across centuries, their encrypted brilliance waiting for tools they couldn't imagine. As spectral imaging peels back their secrets, we're not just reading history, we're finally listening to its whispers. Alchemy's fingerprints are everywhere in modern chemistry, not as forgotten superstition, but as the foundation of tools and techniques we still rely on today. Take the discovery of phosphorus, one of the most dramatic examples. In 1669, German alchemist Hennig boiled down hundreds of gallons of urine, convinced the golden liquid held the key to the philosopher's stone. What he extracted instead was a waxy, glowing substance that burst into flames when exposed to air. Brand had no idea he just isolated the first element discovered since antiquity, but his method, reducing organic matter to its essential components, mirrored the analytical techniques chemists use today. His cold fire became phosphorus, a cornerstone of matches, fertilizers, and even DNA. The irony: alchemists seeking mythical gold stumbled upon a real elemental treasure. Their experimental setups were equally revolutionary. The alembic, that iconic coiled glass vessel alchemists used for distillation, evolved directly into the modern condenser in chemistry labs. The design is virtually unchanged, a testament to their engineering ingenuity. Even the humble mortar and pestle, once used to grind gemstones into magical powders, remains essential for preparing samples. But the real breakthrough was their refinement of acids. Medieval alchemists perfected the production of nitric acid by distilling saltpeter with vitriol, a process so efficient it remained standard until the 19th century. Their aqua regia, a volatile mix of nitric and hydrochloric acids, could dissolve gold, a feat that fascinated Renaissance scholars and paved the way for modern metallurgy. Perhaps most surprising is how their theoretical framework persisted. When alchemists wrote of purifying metals through repeated dissolution and crystallization, they were describing what chemists now call recrystallization, a standard technique for refining compounds. Their obsession with prima materia, the primal substance underlying all matter, wasn't so far from the atomic theory that would emerge centuries later. Even their color-coded stages of transformation, blackening, whitening, yellowing, find echoes in today's chemical indicators where color changes signal reactions. The real alchemical legacy isn't just in tools or discoveries, but in mindset. Their relentless curiosity, their willingness to document both successes and failures, even their symbolic language, all became the DNA of modern science. The next time you see a chemist's flask or read an equation, remember, it's not a break from the past, but the philosopher's stone reborn. Behind closed doors and hidden chambers, secret societies like the Rosicrucians became the custodians of alchemy's most dangerous truths. Emerging in early 17th century Europe, these shadowy brotherhoods presented themselves as invisible colleges, where the pursuit of enlightenment was veiled in elaborate rituals and coded texts. Their manifestos, like the Fama Fraternitatis, published anonymously in 1614, spoke of a mythical founder, Christian Rosenkreutz, who had supposedly traveled to the East and returned with alchemical wisdom. The document wasn't just a recruitment tool, it was a gauntlet thrown at the feet of the Church, declaring that nature's secrets belonged to those bold enough to seek them. New initiates underwent ceremonies steeped in alchemical symbolism, blindfolded to represent spiritual blindness, then led through a series of chambers representing the stages of transformation: nigredo, blackening, albedo, whitening, and rubedo, reddening, mirroring the purification of metals in the crucible. The Rosicrucians' influence bled into later fraternal orders, most notably the Freemasons. Symbols like the compass and square, now synonymous with Masonic lodges, originally echoed the alchemists' tools for balancing opposites: Mercury and sulfur, sun and moon. Even the Masonic obsession with architectural perfection traced back to alchemical texts comparing the philosopher's stone to a living temple built through sacred geometry. When 18th century Masons adopted initiation rites involving mock deaths and resurrections, they were reenacting the alchemical process of solve et coagula, dissolving the old self to forge a new one. But preservation came at a price. To avoid persecution, these societies buried their knowledge in layers of allegory. A Rosicrucian manuscript might describe the marriage of the Red King and White Queen, not as a mystical union, but as a practical recipe for combining gold and silver in acid. Their famed rose cross emblem wasn't mere decoration. The rose symbolized secrecy, sub rosa, while the cross's arms represented the four classical elements, a map for manipulating matter. The irony: these societies, designed to protect alchemy from annihilation, became so effective at secrecy that much of their knowledge slipped into obscurity. When Freemasons like Elias Ashmole, founder of Oxford's Ashmolean Museum, transcribed alchemical texts, they often did so in cipher, leaving later scholars to unravel puzzles wrapped in enigmas. Yet their legacy persists. The Rosicrucian notion of invisible mentorship inspired modern scientific academies where knowledge passes discreetly between trusted peers. And those hushed lodge meetings, they set the template for peer review, just with less incense and more data. What began as a refuge for heretical chemists became the bedrock of collaborative discovery. proving that sometimes the best way to illuminate truth is to first shield it from the light. Dante's Inferno reserved a special circle of hell for fraudsters, but among the counterfeiters and seducers, one group stood out, the alchemists. Canto 29 plunges us into a diseased valley where these sowers of discord writhe with eternal scabs, their bodies rotting like tarnished metal. The punishment is symbolic alchemy's promise of perfect transformation mirrored in their flesh's grotesque decay. Yet Dante's condemnation wasn't just about greed. These figures embodied a deeper anxiety, the terror of humans tampering with divine order. When the poet describes an alchemist's distorted face as no longer human, he captures medieval Europe's fear of spiritual contamination, that dabbling in nature's secrets could unravel the soul itself. Chaucer's Canterbury Tales takes a wryer approach. The canon's yeoman, with his singed robes and reek of sulphur, stumbles into the pilgrimage like a walking cautionary tale. His frenzied monologue spills secrets, the shattered crucibles, the mercury fumes that left him pale as ashes, the master who vanished overnight swindling nobles. Here, alchemy isn't hellish, it's tragicomic, a farce of broken promises, but beneath the satire lies a kernel of admiration. The yeoman's lament, all that glisters is not gold, acknowledges alchemy's seductive brilliance even as it mocks its failures. Chaucer, ever the humanist, paints these seekers as neither demons nor saints, but flawed men chasing an impossible dream. Occult texts reveled in alchemy's mystical potential. The Aurora Consurgens, attributed to Thomas Aquinas, wove biblical allegory into chemical symbolism, portraying Christ as the divine alembic purifying souls. Its stunning illuminated manuscripts show Mary as the vas naturale, the sacred vessel where base humanity transforms into gold. Meanwhile, the Liber Hermetis merged astrology with lab work, mapping purification stages to planetary alignments. These weren't just instruction manuals, they were cosmic dramas where every retort and furnace became a stage for spiritual rebirth. What united these portrayals was duality: alchemists as both charlatans and visionaries, their craft both heresy and holy pursuit. Literature mirrored society's conflicted heart, the thrill of discovery wrestling with terror of the unknown. When Dante's alchemists wail about their vain experiments, or Chaucer's yeoman coughs up mercury-laced confessions, they voice a tension we still recognize: the cost of curiosity when it brushes against the forbidden. Their stories endure because alchemy, in the end, was never just about metal. It was a mirror held up to humanity's boldest hopes and darkest temptations. The 20th century was supposed to bury alchemy once and for all, relegating it to the dustbin of history alongside bloodletting and astrology. But in smoky Parisian cafes and shadowy European salons, whispers persisted that the old master's secrets hadn't been lost. At the center of these rumors stood Fulcanelli, a pseudonymous figure whose 1926 book Le Mystère des Cathédrales claimed Gothic architecture was one vast alchemical cipher. Unlike medieval adepts, Fulcanelli didn't bother with lead or crucibles. His alchemy was cosmic, encoded in the very stones of Notre Dame, where gargoyles became symbols of primal matter and rose windows mirrored the philosopher's stone's crystalline structure. When he vanished in the 1930s, leaving only rumors of a final manuscript hidden in a Spanish monastery, the legend grew. Had he achieved the ultimate transmutation not of metal but of self, shedding his physical form like dross? Or was his disappearance the final sleight of hand from a man who'd turned obscurity into an art? While Fulcanelli wove mysteries, science achieved what centuries of alchemists had dreamed: the actual transmutation of elements. In 1919, Ernest Rutherford split the atom, proving one element could become another. By the 1940s, nuclear reactors were mass-producing atomic number 94 plutonium from uranium, a feat that would have made medieval alchemists weep with envy. The Philosopher's Stone wasn't a powder or elixir, it was a particle accelerator, yet the parallels ran deeper than anyone expected. alchemical texts describing the dissolution of the sun and moon eerily anticipated nuclear fusion, while their obsession with mercury mirrored its modern role as a neutron reflector in atomic bombs. Even the old glyphs found new life. The alchemical symbol for uranium, a circle crowned with arrows, was adapted into the atomic age's radiation trefoil. The most poetic twist, the man who first synthesized gold artificially wasn't a chemist but a physicist playing with stardust. In 1980, Glenn Seaborg used a cyclotron to bombard bismuth with carbon nuclei, creating trace amounts of gold, one atom at a time. It was the culmination of humanity's oldest scientific dream, rendered absurd by its cost. Producing an ounce would have bankrupted nations. Today, we understand why alchemists failed. Their furnaces couldn't generate the millions of degrees needed to rewrite atomic nuclei. Yet their intuition was sound. All matter shares a common ancestry in the hearts of stars, where nuclear alchemy forges gold from hydrogen over cosmic lifetimes. What would the old masters make of our atom-splitting prowess? Some, like Paracelsus, might nod knowingly. He'd written of invisible rays that could alter matter. Others might shudder at the hubris of unleashing such power without their spiritual framework. One thing's certain, their dream didn't die, it evolved. From nanotechnology's molecular tinkering to quantum physics entanglement where particles change states across vast distances, we're still chasing the same fundamental truth, that matter is mutable and reality is far stranger than the boldest medieval vision. The crucibles have been replaced with supercolliders, but the quest remains. To transform, to transcend, to touch the infinite, that's the real philosopher's stone, and it gleams as brightly today as it did in candlelit workshops 7 centuries ago. Medieval alchemists were pioneers walking a razor's edge, visionaries shackled by the very era that birthed their brilliance. They peered into the abyss of nature's secrets with nothing but intuition, crude tools, and the audacity to ask, what if? Their crucibles bubbled with possibilities centuries ahead of their time, yet their greatest discoveries were often smothered by dogma, persecution, or simple lack of technology. Imagine their frustration, fingertips brushing truths they couldn't fully grasp, like trying to describe electricity while trapped in a world of candlelight. They decoded the language of matter long before the periodic table, yet their insights were buried in symbols, their genius dismissed as heresy or madness. What secrets still lie hidden in those coded manuscripts? Libraries and private collections hold thousands of unread pages, recipes scrawled in disappearing ink, diagrams folded into cryptic geometries, formulas obscured by intentional errors to mislead the unworthy. Modern spectral imaging and artificial intelligence are just beginning to crack these puzzles. In 2019, researchers at Stanford used X-ray fluorescence to uncover erased notes in a 15th century alchemical text, revealing a lost method for synthesizing vermilion pigment. What else might we find? A forgotten cure, a chemical process that defies conventional wisdom, or perhaps something more unsettling, an experiment deemed too dangerous even for its creators, deliberately concealed. This leaves us with a tantalizing question. Where does science end and mysticism begin? The alchemists would argue there's no line, that every material truth is a shadow of a deeper spiritual one. Their quest wasn't just about transforming lead into gold, but about transforming humanity's understanding of its place in the cosmos. Today, we've split the atom and mapped the genome, yet we still chase elusive frontiers, dark matter, quantum entanglement, the nature of consciousness. Are we so different from those cloaked figures huddled over their flasks, seeking illumination in the unknown? So tell me, what do you think lurks in the margins of those ancient texts? A recipe for immortality, a warning we've yet to decipher, or simply the ghostly echo of curiosity, relentless as the tides? Drop your thoughts below and let's keep the conversation alive. After all, the greatest alchemy isn't turning metal into gold, it's turning questions into discoveries, one shared idea at a time.